Hi and welcome everybody to this INTERGEO expert interview. INTERGEO is the leading platform for geodesy, geoinformation and land management. And today we talk about Earth observation and global monitoring. We have some amazing guests who will shed light on the important role that satellites, radar, sensors, and geoinformation play in understanding and monitoring our world's environment. So from space, satellites observe the impacts of global warming around the globe, and around the clock they collect important data for researchers on the rise in sea levels, the melting of poles, and the increase in greenhouse gases in our atmosphere. So just to name a few examples. And our first guest is Godela Rossner, and she's head of Earth observation at the German Space Agency, sorry for that, DLR. And Godela has extensive experience in the field of remote sensing and has worked on numerous missions related to Earth observation. She's also a passionate advocate for the use of satellite data to address environmental challenges such as climate change. And Godela, it's great to have you here with us today. Welcome.
Hello, welcome.
So, and we continue with our second guest, and this is Dr. Andreas Müterthies, and he's a scientist who is specialized in environmental monitoring using remote sensing techniques with a particular focus on climate change. And he is head of business development at EFTAS, a German company known for geoinformation and IT services. And he is vice president of DDGI. This is the German Association for Geoinformation. And also a very warm welcome to you, Andreas, and great that you join us here today.
Hello.
So let's start with this talk about Earth observation and global monitoring. My first question goes to you, Godela. Maybe you can start by telling us more about your role at the German Space Agency, DLR, and how the Copernicus Earth observation play a crucial role in addressing issues related to climate change.
Well, thank you, Denise, for having me, first of all. And a few words about my work. So I'm head of Earth Observation Department at the German Space Agency in DLR. And what we do in our department is, first of all, we develop and build Earth observation satellites to monitor diverse aspects of our environment, of the Earth. And we also, of course, promote and support the development of applications to bring these data from the satellites into use, which means before that we also distribute the data and make them available to the user community. That's on the national side, and we are also acting on the European side. So we are steering the programs on the European level, like the Copernicus program that is managed by the European Commission and the ESA. We are working there for the Ministry of Transport, and we are also acting on behalf or in the framework of the EUMETSAT programs, so the meteorological programs, and the ESA programs, which address, well, ESA is, first of all, managing the Copernicus program for the European Commission, but also has a fleet of scientific Earth observation missions to enlarge our knowledge about the Earth. And our role from our department is really to monitor these European programs, to bring in our national position and make sure that what is developed there is also to the benefit from not only on the European level, but also brings back benefit on the national level. So that's what we do in our department, in my department. And your second question was now the role of Copernicus. And the Copernicus program, we really have to say, has been a game changer in the domain of Earth observation. Before Copernicus, most of Earth observation were single satellites monitoring specific features, and we could demonstrate that there is high potential to improve our understanding of the processes on the Earth and to help manage our use of natural resources and so on. But now with Copernicus, we have a consistent and continuous monitoring program in infrastructure that delivers continually data that we need to understand on a global level, but also bring it down to regional and local level. And that's the game changer. So we now have not only a monitoring tool, but also a tool to act on this data, to act on the global level, make sure that we can keep, for example, the temperature goal of the Paris Agreement, that we can make sure that we reach the goals of the European Green Deal, and to transform also on the local level and help, for example, cities to make the environment for the people living in the city more sustainable, that they don't have to suffer from the heat that is increasing, of course, due to the climate change. So just to give a broad overview on what is really happening through the Copernicus program.
Yeah, thank you very much. And shortly we will go into that topic deeper of the role of Copernicus in terms of climate change. So let's continue with Andreas. And Andreas, we just heard that Godela mentioned that Copernicus is a real game changer, that the data of it may help us to act and to do something here. And though this has a big impact, and maybe you can start us by telling about your work and how global monitoring also plays a crucial role in addressing the issues related to climate change and climate protection, of course. And how do you see, I mean, this is the huge topic of today, how do you see the role of global monitoring compared to Earth observation with satellites? So maybe you bring us into this topic first.
Yes, thank you very much, Denise. And also thank you to Godela for the first kickoff with the explanation what Copernicus, this great program, is. For me, it is really a game changer. And it is, since we began thinking about Copernicus, that was more than 20 years ago when we started. Also at that time, presenting the first idea at INTERGEO, Denise. It was in 2002 in Frankfurt. So a long time ago.
Yeah, a long time ago. I wasn't part of INTERGEO. I joined INTERGEO in 2012, so 10 years later.
Yeah, so you see, that is really a long time. And it was a lot of work, but at the end, for me, it is really a great success. In the first years, of course, we did many things on the design of the program, of the satellites, of the things that the satellites should monitor, the development of the techniques, the developments of the satellites itself, the Sentinel missions, and nowadays more on the operational use of Copernicus. So that is my work for 20 years, and it is really a pleasure to contribute to Copernicus on the national and on the European and international level, because with this program, we can support the action on climate change, to monitor what climate change is meaning, how temperatures on a global level develop, how global warming is taking place, how rainfall is modification of rainfall in Europe and worldwide, and also in Germany on the local level. So we see a lot of things, how climate is changing with Copernicus, with the missions we developed during the last 20 years. That alone is a great success for me, for Copernicus. Having this tool to enable us to monitor on a global scale how climate change is taking place. It's unique. I can say there is no other program who can do this. So that's the point. Europe made it, we contributed to it, and that is really great work, and I liked to do it for 20 years. On the other hand, it's not only climate change monitoring. More important, it's climate change impact monitoring, meaning not only to look at temperatures and rainfall, but to look into detail what is happening on Earth. how is the interaction between this climate change and land use, land cover, welfare, all these things on a global scale, taking a close look how our land cover on Earth is changing due to climate change, how desertification is coming on, large areas which are unlivable today. So we see these developments. We see it very soon, very early, very complete on a global scale. Also on national and subnational level. Take a look at the drought we see and we faced here in Europe, in Germany, destroying our forest. We see this with Copernicus, with the eyes of Copernicus, with the Sentinel mission, also with the contributing mission. So this data, it is really, really a game changer, but it only works if we do not only look at the spaceborne data, the satellite data, but we combine it with the so-called in situ data, one of the most important components of Copernicus, in my understanding at least. So we also take the data, mission data, satellite data, high altitude platform data, airborne data, drone data, and data from sensors on Earth. And the ancillary data, the geodata we have on our data archives. This compendium of data and the combination gives the information we need to monitor these serious developments we are faced by climate change. Having this information on climate change impact, for me, the most important thing is not to stop at that point, but to have the instruments of Copernicus and the techniques also to monitor and to see how our activities to mitigate climate change, to modify our way of life, to adapt to climate change, monitor how these activities, how they develop, if they are successful, if all these activities come to a good result. Talking about, for example, the program from the European Union, talking about national programs to combat deforestation and desertification. So all these things are very necessary to see if we do the right things to stop this development, or at least to mitigate some of the effects. So that is, for me, the most important thing, to have an instrument to see if our activities to combat climate change and climate change impact are on the right way. There is no other instrument for that.
Thank you for emphasizing the role of the observation tools and monitoring and research works on that, and how important it is to act and to handle, as you just mentioned it. And maybe we just continue, Andreas, at that point into the deeper topic of climate change, as you already just mentioned, and we are going to concrete examples in that thing, because the EU is working on a law on supply chain called the Lieferkettengesetz, and that will focus on remote sensing as a tool for sustainable production of goods, such as very important palm oils, for example, or soybeans, and wood or timber production. And how is it concrete going to work things there? Because remote sensing and geoinformation, you talked about that with my colleague before, is really a technique which is so important to develop that or to continue in focusing on that topic.
Yes, thank you very much for this idea. Having a tool to monitor on a global scale what is happening means also that we have a tool for controlling if any action against these developments is on the right way. So this supply chain law of the European Union, which is in preparation, is really a very, very important law, just to prevent that for the production of these commodities like soybeans and palm oil, any kind of serious impact on our environment takes place, namely the deforestation aspect. So this means having these instruments, we have the capacity to monitor if these products are produced under sustainable conditions. so that we can be sure that there is no deforestation taking place on the sites where these commodities are produced. So therefore, we need the satellite data. We need optical data and radar data to monitor the production also on very broad regions, on regions far away from Europe, like in South America, for example. We cannot do these monitoring if we do not have the data, and Copernicus is delivering this kind of data.
Thank you very much. Godela, let's continue. You also started with the topic of climate protection and the role of Copernicus has in that. And Copernicus has a lot of different satellites who deliver data to us. And you also mentioned in a talk before with my colleague that there is one called, let me check what was the name of the other one. It's where's the name? The Sentinel 5P. Sorry, I haven't read about that before. It's Sentinel 5P. So in order to achieve the Paris Climate Protection Agreement, control mechanisms are necessary. We just talked about that. The focus is on reducing the global emissions of carbon dioxide. And how does the use of satellite data, just from Sentinel 5P, for example, help in understanding and monitoring greenhouse gases? How do you work with that, and could you just describe that to us?
Yeah, okay. So Sentinel 5P, what does this P stand for? It's a precursor mission, and it's one of the satellites of the Sentinel family that observes the atmosphere, like Sentinel-4 does as well in another orbit. And they're meant to measure the concentration of certain greenhouse gases or atmospheric gases to better understand what's going on in the atmosphere. I have to say, with respect to the Paris Climate Protection Agreement, these are also kind of precursor missions, because what we are now building with the Copernicus program is the CO2 mission, which is really meant to have a global monitoring and quantification of the emissions of carbon dioxide. And we also have missions to measure the methane concentration. Those are the two major relevant gases, greenhouse gases we have to monitor, and we want to understand how much is the increase of their concentration in the atmosphere, because what we have so far is reporting, international reporting. I mean, that's why we're talking about global monitoring, because we have global processes and we want to monitor it on a global level. We have to agree on an international level how to deal with it. So what is now being done to monitor the concentration or the emissions of the greenhouse gases is that it's built on statistics from the different countries. So they are looking at their industries, their farm production, cattle and milk production, and all these and building industry, all this feeds into the statistics on what is emitted over a year. But there are, of course, bigger uncertainties in these reports than on greenhouse gases, greenhouse gas emissions. So what we use the Earth observation and the Copernicus satellites for is to verify and to really monitor the distribution of the concentration of the greenhouse gases over the Earth, over the planet, and to model back. So because the greenhouse gases are distributed by the winds, so you cannot say where you see a lot. Those are also the emitters. They can be somewhere else. But we want to understand how this is going on. So we use the Earth observation combined with models to really draw it back to where is the emission really happening and to verify what is being said in the reports. So what we are working on in a combination with other international space agency to build up a control tool or a control system that integrates Earth observation to have a regular update on the global stocktake for the Paris Agreement to make sure that we are on the right path. And this is new and this is unique. So this has been also agreed, for example, at the last COP, where it has been said that now Earth observation has to be systematically be integrated for this kind of monitoring with respect to the Paris Agreement. So that on the one side, and also on our national level, for example, the German Weather Forecast Service, the DVD, the Deutsche Wetterdienst, is working on an integrated greenhouse gas monitoring system. So because DVD, together with the National Environment Agency, is responsible for these reports. And they are now working on also an integrated system for the national level, for the national reporting for the Paris Agreement. And this is where the Copernicus data really feeds in, and where we are hardly working on it. CO2 EMS, or the carbon dioxide mission, is currently being built. It will be launched in 2026. And it's really challenging to have the accuracy in the data to really match what we need as data information on the concentration of these greenhouse gases. But this is what we are going for, to have this global monitoring really at the precision that is needed to really get the climate change, get the greenhouse gas emissions under control. So maybe this on this greenhouse gas aspects. Of course, there are further aspects, like what Andreas just said. If we look at deforestation, because that's the other hand, that's the other side of the emission chain, or the carbon cycle of the Earth. The main reserve of carbon is, of course, in our forests. So it's crucial to see their state and whether they are degrading or whether we can rebuild the forest and the biomass. So, of course, Copernicus on that hand is a tool to support that the mechanism we put in place to decrease the amount of greenhouse gases in the atmosphere has to work together. So we have to look also on that side, where the forests and what status are there. Can we rebuild the biomass in the forests and in other natural bodies? So this is also very important, and can also be supported by, of course, then other Sentinel satellites, like, for example, the Sentinel-2, with very good qualities in monitoring the vegetation, or the radar satellites, because a lot of our forests are in the tropics, and there are a lot of clouds. So we need something that can look through the clouds and observe the status of the forest. So Copernicus really offers this integrated monitoring tool, these instruments, to help on all sides of what we have to deal with the climate change.
Yeah, I would just mentioned also the deforestation, and before it was something which I think is really sometimes, I mean, a bit disillusionating, because we have the accuracy, we can see exactly where the emission is or where the problems are, and it could be solved. But as you just mentioned, COP and so on, there often is no idea how to solve the problems by acting, by getting a real solution, by doing things better. I guess from all the imaginary satellite data, you can see it, all the waste, the plastic waste on the oceans. You can see the emissions of carbon dioxide. You can see the pollution everywhere, but sometimes it has to be done so much more. And I think this is the very important thing. This is also the thing why we want to bring it, the topic, so on a focus at INTERGEO, that you can see, okay, there is Earth observation and global monitoring. It's so important. We have that data. We can see it. We can measure it. We can see the impact. So let's get in action for planet Earth as well. So this,
exactly.
I think this is also a very important part.
Exactly. So the information has to be actionable. It's about acting on it. And maybe two aspects I would like to add. So as we already talked about, this supply chain law that is put in place, this is about getting to action, because now people and now the producers are accountable for what they're doing. Where's the wood coming from? Is it some protected area, or is it a managed forest that is meant to be used for wood production, for example? And also another example concerning the greenhouse gas emissions. In our report so far, there are sources of greenhouse gases, of methane, that haven't been accounted for. There are over 900 drilling platforms in the North Sea, and they're producing like 70,000 tons of methane per year. And methane is much more effective on the temperature increase than carbon dioxide. And this hasn't been seen, this hasn't been included in the reports, because people thought there weren't so many emissions and no diffuse emissions, but there are. This has been scientifically proven through the use of Earth observation data. So the Earth observation data can complement our understanding of the sources of the processes, and can make people accountable. The industries who are producing and who are polluting the atmosphere at that point. And complementary to the Copernicus system, we also see a number of commercial satellites that are also completing the picture, because they are mostly focusing on very high resolution, not only in the optical domain to better understand what's going on in the streets and in the vegetation, but also now more and more to observe the sources of greenhouse gases. And this is also due to the effect that the laws are being put in place to make people accountable. So industry and space industry is now building on that, a new business, and supplying data, high resolution data, to monitor where are these sources, to really find the points, the needles in the hay, where are the ones that are putting the emissions into the atmosphere. And yeah, that's really to make, not to only have the information to everyone, but really to get to action and make people and industry accountable for what's happening. And to measure, of course, the effects, the legislation of our policies, whether this is really steering everything into the right direction, that we can handle the climate change.
Thank you. Right now, I would like to have a look at the sector of energy and energy transmission. At energy transition. Sorry. So let's focus on that. And yeah, we're working towards sustainable sources. Godela, you just mentioned the drilling platforms, deforestation, which also means coal, oil, gas, and so on. We know this is endable, but we're still dependent on it. And yeah, we're looking with the help of Earth's observation for a sustainable form of energy. And yeah, so and I think, Andreas, you can give us an overview of that with some pictures you also brought with you, or that you've been working on, how some of these projects that we can maybe see, or you can explain right now to us, have contributed to our understanding of climate change. And maybe it's the gas emissions, maybe it's some Earth observation. Let's have a look what you brought us there from the global monitoring.
Yes, so let's take a look at the images behind, because we are talking about data and we present the data in form of images. So I think this is self-explainable in some way. So I brought along some slides for you just to show what we can see and how we monitor these things. So let's start with the data we are talking about, the Copernicus Sentinel data, for example, here with, for me personally, the most important missions, Sentinel-1 and Sentinel-2. If we talk about the global monitoring, Earth's observation for monitoring of climate change and climate change impact, coming from energy supply, coming from any kind of action and the interaction with our land cover, we can see the impact using this kind of data. So we see on the left side the Sentinel-2 data, on the right side the Sentinel-1 data for a small piece of land, in this case here in Germany. So this is a river basin of a small river, and you see a landscape with forest, with agriculture, with settlements, and the data shows how the land use and land cover is developing over time. And the time slot I've used here is from 2016 to 2021, including the severe drought we saw in this region in the year 2018, 19, 20. The reason why we monitored this was another one. So it was by chance that we also have the impact of drought on the region here. This is a post-mining region. It is in the north of the so-called Ruhr area in Germany, one of the most important coal mining regions in the world for nearly 150 years. Coal mining here stopped in 2018, but the processes, the interaction with land cover is still going on, because also in the post-mining phase, land surface and the underground is still changing. For example, due to the impact of the lift up of the water in the mine, the so-called mine water level. So this is rising because this is not pumped anymore. So there is a change in the underground causing also changes on the surface. So we have here a mixture of interaction with land cover. So what we see, this is the raw data, optical and radar data, and we used it, for example, to monitor changes in the vegetation cover. This is seen here on the right side with a special index, the vegetation index, showing the vitality of vegetation. So in this case, changes in the vitality coming from seasonal changes, of course, winter and summertime, also changes from the mining industry and changes from drought. So we need to differentiate, but first of all, of course, we need to understand the kind of change we see. And therefore we use this kind of data just to map, for example, here, how the forest is changing. And we talked a lot about forest changes on a global scale due to deforestation. And one factor for deforestation is drought in relation to climate change in this case. And so we see that the vitality of the forest trees is degrading, and in some cases, in some regions here, the forest is dying. So you see it here with the red delineation. And if you use this fully automatic method on a global scale or on larger region, you can monitor deforestation, in this case due to drought. And it was done, for example, here by the Ministry of Environment and Agriculture of the state of North Rhine-Westphalia to monitor the loss of forest due to drought in North Rhine-Westphalia for the whole country. And you see here how severe this development is over time. Fully automatic, based on Sentinel-2 data, and the severe impact is seen. So this is one example how we monitor deforestation, independently if it comes from drought or from the production of raw materials. And I will show you an example. So this is simple stone, you can see, a gold ore stone. This comes from Romania. Take a look how it was produced. We can do that by remote sensing. I have been there 6 years ago. So it comes from this region, Transylvania. So there are many gold mines in this region, and this beautiful scenery you see looks really nice, but in fact, this is a tailing pond with the remnants from the mining industry. And these tailing muds, it's stored, and therefore the people built tailing dams. This is the dam for this tailing pond. Looks nice, nothing very important, you can think, but in fact, this dam broke in the year 2000. And all the tailing went into the river system, running down to the Danube River. And the tailing contains cyanide. So there was a poisoning of the Danube River ecosystem with severe reactions, of course, of the river system, but also severe consequences for the mining industry in Romania. It completely broke down because of this event. So why did it happen? Because the dam broke, of course. Can we prevent it? Yes, we can, if we use the right data. And we can do this with the Sentinel data, for example. Let's take a look how we do this with Sentinel-1 radar data. So this is another tailing pond, not in Europe, but in this case, in South America, in Brazil. And you can see there is a pond, there is a dam, and this dam also collapsed in the year 2015. We see from the Sentinel data that the dam was moving. And we can say that using this data in some of these events, we can prevent, maybe. At least we can use the information to warn people, to prevent that there are injuries, dead people like it happened here, and to prevent that river ecosystems are poisoned, polluted by the tailing. So this is only one example for the energy ecosystem, for the energy production, for the production of raw materials. Talking about the energy transformation to renewable energy, we can also use the same information from radar data, for example, to use it for the monitoring of the elements we need in the future energy system. So let's take a look how this is monitored in Germany. This is a data set of the Bodenbewegungsdienst Germany. And you can see there are different colors, meaning different movements of the Earth. In red, we see subsidence. In blue, we see an uplift. So let's move into the data, zoom in, and we see there is a large blue point here in the northern area of North Rhine-Westphalia. And this blue uplift regions, it's also coming from the mining industry, from a former mining site in Aalen. And if we go in there, we see that we have settlements, we have movements on these buildings. We can also take certain points of this data set. We can visualize the movement over time, and we see that, for example, this specific point here in the settlement is moving upward for 8 centimeters over the time. This is a lot. In that case, I know that there was no damage to the building, but I know it only because this is my building. So I took it as an example. I know the building is okay, but that must not be the case. Of course, there can be damages, and we see it if we take another region nearby here with the red circle. And I went there and I see here the street is damaged. You see the machines for the repairing of the street. And we know that here in that case, this damage was caused by a geological fault in the underground, here seen in the geological in situ data. So combining this kind of data, the in situ data for the geology with the remote sensing data, we can create new maps. having the whole information in situ data and remote sensing data, Earth observation data enables us to understand the processes. In that case here, we used the data set to monitor an underground cavern for oil and gas. And there we come to the energy transformation. These underground storages in future can be used to store hydrogen. Very important because we have the production of energy by solar energy, by wind energy, but we need a storage for the dark, windless nights. This is one of the storages, and we can monitor ground movement caused by the storage, caused by other factors, just to prevent that there are serious injuries on it. So this is the reason why we use the data. And again, this data is available on a global scale. This is the power of Copernicus.
Wow. I'm a bit impressed and overwhelmed. You know, I'm a journalist, so I'm not kind of the geoinformation experts or land management, or as you do for space agency or engineering and so on. So this is really impressive. What the power of this tool of Copernicus and imaginary has. It's really amazing. So you just mentioned the energy. And the energy transition, deforestation, and so on. That's awesome. Godela, one other thing we would like to mention here is the point of disaster monitoring. And Earth observation, of course, is also very closely linked to disaster monitoring. And as Andreas also just mentioned, droughts and floods cause major damages. He demonstrated also some in this context. We have them ecologically, economically, and socially. And these natural disasters, we all remember the big earthquake in Turkey and Syria. These cost countless lives, and the reconstruction work, of course, which will continue in this area, for example, takes years or even decades. And what contribution does the satellite-based Earth observation make in this environment of disaster monitoring? Can you also give us there some examples or range of examples where satellites and observation absolutely make sense and help us and bring us into action?
Yeah, there are several examples. And if you recall the earthquake of Turkey and Syria, this has been, of course, devastating in this year in this dimension. We've never seen an earthquake affecting such a large area like that one. The first thing that Earth observation can deliver in such case of natural catastrophes is to deliver data and help the people, bringing help to the sites to have an orientation to see which areas have been affected, how much has been affected, to estimate in combination also with statistical data on the inhabitants to estimate how many people could possibly be affected. So how much help has to be delivered also on the covering health issues and drinking water and clothes and whatever could be needed. And so that's what's, for example, been organized through the International Charter for Space and Major Disasters, where several agencies work closely together to start the mechanisms and have, as soon as possible, the highest quality data that fits to the specific catastrophes, and also transform this data into information that can be then used in the field to manage the help mechanisms and to tell, for example, the technical help service, or the THW, where to go about and help people. So this is the first step, and it's not only located on the international level, but we also have a dedicated Copernicus service for emergency management that also helps in in direct response to such catastrophes. And also, for example, the flood in the River Valley that happened 2 years ago has been also a very large disaster that we haven't seen in that dimension before, where we also delivered very soon data on where's the flood happening, how large is the extent, which people, which cities are affected, and how could we help. And not only to see the dimension of the disaster, but also there, for example, in connection to this flood in the River Valley, we have also seen the benefit of the soil movement services that Earth observation data, and specifically the radar data and the X-band data, can deliver, because it was used to to have a look at the buildings that were close to the areas affected by that were flooded away. Let's put it like that, through the water, whether houses got unstable, so could be could break down, for example, later on. So how was the movement of the building through these immediate effect? This can also be used. Of course, also another hot topic are the droughts and the fires we are observing. So the number of fires we have in Europe has dramatically increased over the recent years. And here it's not only about looking at the fires when they take place, where are they, where have the helicopters go about and bring the water in and try to manage and get the fires under control, but it's also beforehand. So we are not only talking about disaster response, but more and more, of course, about disaster management and preparedness. So given the fact that temperature is increasing and that the drought of the soils is increasing, because it's not about precipitation, that's one factor, but it's mostly about temperature, and what of the water is already has disappeared in our soils and in our deeper soils. So this is increasing the risk of fire. And we can also observe that through Earth observation. Not only the temperatures, but also we have missions in place, like the GRACE mission, that helps us to understand the water cycle and the water amount in the body on larger scales. And this will help us to better understand where's the risk the highest and what can we do to prevent catastrophes to happen. So those are two examples. Yeah, of course, there are also man-made catastrophes which we have to deal about. I mean, man-made in the sense of Andreas just mentioned. So if we have a tailing dam that is breaking down, well, you want to prevent it beforehand, but when it happens, you want to know, well, what kind of areas affected? Is it only the people, but is it also maybe the drinking water for the area? Where is cyanide or other heavy metals are affecting the environment and lands? And also the instability of the ground due to coal mining, for example. This is, I mean, an ongoing effect that we see, especially in North Rhine-Westphalia, but also other areas in Germany, where we want to make sure that we have everything put in place to prevent that it's happened, so that we monitor in a very early stage the instabilities and to make sure that no one gets to harm. But still we have the catastrophes. We have, for example, the Ostsee in the Lausitz area, where we have had this instability in the riverside, where houses broke down and people died. So we have to manage that, and Earth observation is a tool to help to prevent and manage these kind of catastrophes.
So when I listen to your stories, the impression is, and the conclusion is that in all challenges we are actually facing, global monitoring and Earth observation plays an enormous role and has an enormous potential, and there is enormous accuracy in it. And well, we just have to focus it in the role it will play at INTERGEO in the next over the next years. And I think Andreas, I think you agree when I say it has a big role in the platform for geoinformation, geodata, and land management. That there is the place for global monitoring as well, of course, naturally.
Yeah, definitely. So this is my hope and my understanding that also the development of INTERGEO to present, to talk, to discuss about the topics of Earth observation, about global monitoring. This is really, really a very important development of INTERGEO. And I hope that we will have the chance to participate, to show what Earth observation can do, how the society can use Earth observation and global monitoring to see if any action on the mitigation of climate change is really working, if we have benefits on the action on the Green Deal and all the things that are done, just to see if we are on the right way. So this is, for me, last point, this is very important. In industry, we have this PDCA cycle, plan, do, check, act, as a cycle just to steer a company. So we are steering a planet, right? And the PDCA cycle, the C, the check, this is Copernicus, this is Earth observation. And if we do not check, we are blind as a society. We will not see if we are on the right way. So I hope we will talk about this at INTERGEO in the next years.
Thank you very much for joining this INTERGEO talk with Godela Rossner and Andreas Müterthies. Thank you very much for being here.